All right, we are covering chapter 1, section 4, perimeter and area in the polygon in the coordinate plane, classifying polygons. All right, looking at this, what is a polygon? It means many angles, okay? Polygons have 3 or more sides. Things we need to know about polygons is that they are closed figures, okay? A polygon is a closed figure, meaning it shouldn't have any openings in it. Okay, there should be no openings in a polygon. Other things you need to know about polygons is all the sides must be straight. You cannot have curved sides on a polygon. Each side must intersect exactly 2 sides, one on each endpoint. So what does that mean? If I have a polygon, I'm going to draw it right next to it. If I have a polygon, let's say it's a rectangle, I cannot have anything intersecting my sides, okay? This is not a polygon. Why? Because if I'm looking at this shape, I have intersections going through my sides. I cannot have that. It has to be one shape in total. So I cannot have shapes within shapes. So if I'm looking at this, I could say, okay, I have a triangle here. I have a triangle here, triangle here, triangle here, triangle here. That cannot happen. It has to be one single shape. So then the next one says, no 2 sides with a common endpoint are collinear. Again, I cannot have a side with multiple points. Okay, I cannot have that. Absolutely no. And then each endpoint of a side is a vertex of the polygon. What does that mean? If I'm giving you a triangle, my endpoints, I'm going to highlight them right here, are called my vertex, my vertices. Okay, vertex is one, vertices is many. Those are called my vertices. So my endpoints, technically my corners, are called my vertices, those specific points where they meet. All right, identifying the figure that are not polygons. Looking at A, is this considered a polygon? Yes, good. Is B a polygon? Why? Good, there's an opening right here. All right, looking at C, the first star, is that a polygon? Why? Good, there are those intersecting lines. Okay, looking at the other star, is that a polygon? Yes. And then the last one, E, is that a polygon? No, that's just like a, I don't know what that is. A windmill?
A Y.
A Y. It's a Y. It's not even a shape. Okay, do we understand what makes a polygon a polygon?
Yes.
Okay, thank you. All right, convex polygons. If you're looking at the slides, this one's convex, the next one is concave. The difference between there is the word cave. Okay, convex just means if I were to continue drawing these lines, if they were to continue on and on, they do not cave inside my polygon. They don't go inside. Okay, all of the lines are continuing on the outside of my polygon. Okay, same thing with this image. If I were to continue drawing those lines, they are not going in. They're not caving in. They're staying on the exterior. Now, if I'm looking at concave, you can look at it. Think about if you're in a tunnel, it's starting to cave in. That's what this one means. Concave means it's caving inside my polygon. Caving in polygon. Okay, so again, looking at this image that they're providing, if I were to continue drawing these lines, they're caving in my polygon. So it's going on the inside. So again, this is caving in. It's going inside. Do we understand the difference?
Yes. Yep.
Okay. So if it's concave, it's caving in. If it's convex, it's staying on the exterior. All right, classifying polygons, we should probably know half of these names. If not, hopefully we find little tricks to remember them. 3, we should already know. 3 is a triangle. 4, we should know, quadrilateral. 5 is a pentagon like the government building. If you have never seen it, it is literally in the shape of a pentagon. 6 is a hexagon. Hex is a way to remember it. So you have the word 6. Hex, they both have that X in there. Heptagon, if you come up with a trick to remember that one, let me know. But you just kind of have to memorize that one. 7 is heptagon. 8, think of an octopus. Octopus have how many tentacles? 8, so octopus, octagon. 9, you have a nonagon. So think of the actual number 9. 10 is a decagon. 12 is a dodecagon. If you're noticing, there is no 11. 11 would just be called 11gon. And anything after 12 is just that number gon. So again, if I had 15, it'll just be a 15gon. If I had 20, it'll be a 20gon. If I had 100 sides, it will be called a 100gon. Okay. Please, 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 come day of the test or quiz, whenever you guys get tested on this, please do not try and merge 2 words together. It is not going to work. Please be exact with your answers. I understand if you have an extra letter or a missing letter somewhere, as long as I understand what you're trying to write. Again, do not try and put 2 words together because it's not going to help you. Choose one. All right, looking at these, it says tell whether the figure is a polygon and whether it is concave and convex. So if it is not a polygon, you don't have to worry about convex or concave. So looking at A, is this a polygon? Why? Good, it has that intersecting line right here. Looking at B, is this a polygon? Yes. Is it concave or convex? Good, convex. C, is this a polygon?
No.
Why? Good, no. Why? Because this is curved, also known as an arc. And then looking at D, is this a polygon?
Yes.
Yes. Is it concave or convex?
Concave.
Good. Ooh, concave. Again, if you want to draw those little caving in, you can see that it's going inside the shape. But if I'm looking at B, it's staying on the exterior. Questions on A, B, C, and D? Okay. All right, before I go ahead and answer these, I want you guys to understand what those little red marks mean. So as we get further in, you'll see these, you'll be using these. What these little marks are called congruency marks. Okay, if I'm looking at these, this is telling me what is congruent, and what does congruent mean?
Same.
Equal, the same. So if I'm looking at this, these little tick marks, those are congruency marks. What that is telling me is these sides are going to be the same exact measure. The curved lines are for angles. These are telling me that my angles are going to be the same measure. If I'm looking at B, you can see that they have some that have 1 mark, while others they have 2. What that means is if this side is 4, this side is also 4. If this side, let's say, is 16, this side is also going to be 16. And same thing with my angles, okay? This angle is going to match the same as this angle. So it's like a game of matching. And this angle is going to be the same measure as this angle. if it is a square. So if we're looking at this one, you see those little squares? What do those equal? Right angles, which is how many degrees? 90 degrees, okay? Do we all understand what those little red marks mean? Okay, so now let's go ahead and answer these. It says classify the polygon by the number of sides. Tell whether the polygon is concave or convex. So looking at the first one, A, how many sides are there? Okay, we'll say there's 6. 1, 2, 3, 4, 5, 6 sides. And what is this shape called? Good. Hexagon. And then is it concave or convex? Good. All right, looking at B, how many sides are there? Good, 4 sides. What is this shape called? Good, quadrilateral. And then concave or convex? Good. Looking at C, how many sides are there? Good, if we count it correctly, 12 sides. And what is that shape called? What is it? A dodecagon. Dodecagon, is it concave or convex?
Concave.
Good, concave. All right, finding perimeter and area. I want to say you guys will be given these formulas. Whatever formulas you're given on the SAT, we most likely provide to you. But please make sure you know how to use the formulas. So looking at this, depending on how you were taught, triangle, the formula for area of a triangle, I normally like to write it as area equals base times height divided by 2, because I don't really like seeing that fraction there. But most of the time, you will always see this one on a formula sheet. All right, rectangle and square, formula for areas are very similar. Length times width, side squared just means side times side. But I normally like to write it as area equals base times height, which is the same thing. Okay, do we know how to find perimeter? What does the word perimeter mean? Good, just the measurement of the outside just means to add all of the sides. All right, looking at this example, it says find the perimeter of triangle ABC and the vertices with the vertices A, B, and C. So first thing for this is you're going to go ahead and plot your points. Please label them. I have -2, 3. That's my A. I have 3, -3, which is my B. And C, which is -2, -3. Go ahead and connect your dots. Ooh, I'll do a little better job. All right, so looking at this, we're finding perimeter. That means we have to find all the sides. Looking at this image, which sides can I find first? Which segments? Can someone tell me one? What was that? AC, okay, I can for sure find AC first. Segment AC, what would be the measurement of segment AC? 1, 2, 3, 4, 5, 6. Yes. And what is another one that I'm able to find? Good. CB. 1, 2, 3, 4, 5. Okay, and all I have to do now is find AB. How would I find AB? Good, I'm going to use my distance formula. So yes, distance formula, we're still using that. If you don't remember the formula, please memorize it. I will go ahead and write it down for you. You have x1 minus x2 squared plus y1 minus y2 squared. Okay, again, we are only finding AB. So I'm not using point C. I'm just going to highlight what I'm using right now, and I'm going to go ahead and plug it in. So using my formula, I have -2 minus 3 squared plus 3 minus -3 squared. Negative 5 squared plus 6 squared. 25 plus 36. Square root of 61. All right, can I simplify the square root of 61? Good, no I can't. So last thing I'm going to do is add all sides. So looking at it, I'm going to add all my sides that I have. 6 plus 5 plus square root of 61. What can I combine here? Good, my 6 and 5, and what does that equal? So I'm going to get 11 plus the square root of 61 units. That is my answer. Please, please, please do not write your answer as 11 square root 61. That is multiplying. We are not multiplying them. We are adding them together. Any questions on example number 3? All right, now this question is asking for area. That's what they're asking us for. It says find the area of triangle DEF with vertices D, E, and F. So again, same thing. First thing we have to do is graph our points. So D is 1, 3. Oops, not negative 1. D is positive 1, 3. E is 4, negative 3. And F is negative 4, negative 3. Again, connect my dots. And what is the formula for area of a triangle? Good. Base times height divided by 2. And I'm able to find that information. Who could tell me what is my base measure? Okay, all I have to do is count. 1, 2, 3, 4, 5, 6, 7, 8. Let me make that a lowercase b. All right, and my height. What's the most important thing when I'm trying to find my height measure? Does anybody remember? Yes? Sorry? From the base to the top of my triangle, meaning it has to be that 90-degree angle. You have to take the height that is the 90-degree angle. You cannot take the diagonal line. So for my height, same thing. 1, 2, 3, 4, 5, 6. And now all I have to do is plug it in. What am I multiplying by? My base times my height divided by 2. If I multiply correctly, what's 8 times 6? Okay, what's 48 divided by 2? 24. So that means my answer is going to be 24 units. Anytime you're using area, your answer is always squared. Okay, please do not forget to write your units. Yes, you have to write your units on your test or your quiz. Questions on example number 4. Okay, homework is PDF on Canvas. Please complete it in Notability.